Good morning, everyone. As part of this video, I'll be discussing about object-oriented modeling and design. Again, I'm Dr. Satishanand Srirama, an associate professor at University of Hyderabad. So, as part of this video, we'll be seeing, I will try to give you some introduction about what is object-oriented modeling and design is concerned. We'll look at object-oriented essential characteristics, okay, and then we'll discuss about object-oriented development and object-oriented methodology and the essential object-oriented themes are concerned. Okay, so we'll be discussing about all the things. So, object-oriented modeling and design, this is a way of thinking about problems using models organized around real-world concepts. Okay, so that's the fundamental idea. It's a way of thinking actually, okay, of problems using models. The fundamental construct is the object. Okay, so everything runs around objects, and actually object combines both data structure and its behavior. Say for example, if you think like a car is an object, okay, so what would be its data structure? So basically like it will have some sort of okay, so it need to have an engine, it need to have some petrol, okay, so it will have some maximum speed, etc. These basically constitute its features, so that is the data structure for that one, and it will have some behavior. Okay, so you basically need to drive it, isn't it? The driving is the behavior of that particular object. Okay, so object oriented actually means that we actually organize all the software whatever we are developing as a collection of these sort of discrete objects. Okay, we'll discuss about all these things in detail. Okay, these are the fundamentals, things like which we need to remember. Okay, object oriented means like that we actually organize the software as a collection of discrete objects. Okay, there are certain essential characteristics which actually make it as an object oriented approach. Okay, so they are identity, classification, polymorphism, and inheritance. Okay, so let us discuss each and every one in detail. So what is identity? So as I already mentioned, data is actually organized into these sort of discrete and distinguishable entities called objects. Okay, and each of these objects has its own identity. Okay, that is the essential feature like which we are discussing now. Okay, so even if there are two objects which have, say for example, all its features which are attributes are the same, and their values are also identical, even then these objects are not identical actually. Okay, these objects can be concrete or conceptual objects. Okay, in real world, like say for example, objects will be simply existing, a car will just exist, but within a programming language, okay, each of these objects will have a unique handle by which it can be uniquely referenced. Okay, the handle can be implemented by, say for example, certain address in physical space, okay, in the memory, or like an array index. Okay, say for example, there is an array, there are different objects within that array, and say for example you are trying to access the second object there. Okay, or a unique value of an attribute as well. Okay, so this is the basic identity. An object can be referenced with in some form or other. Okay, and that basically gives its identity is concerned. Then there is this classification. Objects with the same data structure, so that is my, like say for example with all these sort of same attributes, okay, similar attributes and similar behavior, which is also called as operations, they are basically grouped into a class. Okay, a class is an abstraction that actually describes properties important to an application and ignores the rest. Okay, that's the fundamental idea. Now if we really think in terms of an car as a class, okay, of course an object is an instance of a class. Okay, and this car as a class will have certain attributes. Say for example, it will have this sort of fuel, okay, and it will have this sort of max speed which I have discussed already. Okay, and then like it will have certain operations. Okay, say for example like refuel, get fuel, okay, and then like drive is one of the thing, and then so on. So this is a class. Then say for example all the different types of cars, different cars, okay, a Polo car or like a Renault car, okay, a Maruti Suzuki car. So all of them become like objects. Each of them will have, say for example, their own attribute values and also like method implementation. Okay, so that is the thing like which actually this classification is all about. Okay, then Inheritance is another very critical feature of this object-oriented, okay, concepts. Okay, the inheritance means it is like sharing of attributes and operations among these classes. Okay, based on some sort of hierarchical relationship. Say, for example, there will be a super class. Okay, and there will be a subclass which will be actually extending this super class. Okay, so that means like it basically gets some general information, okay, from its superclass. Okay, so a subclass B basically gets this sort of extends this superclass A. That means like it basically gets some general information from A that it can basically refine it, okay, and then like it can elaborate it. The subclass can basically do that. So each subclass incorporates or inherits all the properties of its superclass. So B will get everything from A and adds its own properties, unique properties, additional properties. This B can basically extend it. That is the basic idea of inheritance. Now let us try to think in terms of a simple example. Say, for example, if there is a window class. Okay, say for example this is the screen on this computer. So basically like if this is the window, okay, so basically like all the space we are defining with a class called uh, window. Now the point is we can actually define subclasses, so which can be a scrolling window like in your browser. Then you will have this sort of scroll bar using which like you can actually go up and down. Okay, these are the additional features you are actually adding to this sort of scrolling window. Okay, that becomes a subclass, and that feature itself is an inheritance. So the basic window will be there. You will be extracting all the features, so the window will be looking exactly the same. But then, like since it will be a scrollable window, you will have this sort of scroll bar. Okay, to the right side. Okay, you know about the browsers. Very simple. Why we actually use inheritance? This greatly reduces repetition within designs and programs. Okay, I mean like every class you design, like you don't want to put all the features and implement everything again. Okay, these things like we'll try to see as part of the labs. Then another very important feature is the polymorphism. Polymorphism means like the same operation. Say for example, whatever the action or transformation that you want to perform on an object, okay, may behave differently for different classes. Okay, assume like there is a chess object, okay, chess playing object, okay, in this one like say for example, and all the objects are extending this one. Say for example, a pawn also extends that, and the queen also extends this chess piece. Say for example, that is the basic class. Then the way like a pawn moves and a queen moves will be different. So that means like the method or the operation which this particular class, say for example the pawn class, will be implementing move will be different from the way like a queen class will be implementing that. Okay, so that is the polymorphism. So basically in terms of these classes are concerned, a specific implementation of operation, okay, of a certain class, we call it as method. Okay, so we use them interchangeably, operation and method. Okay, but then conceptually at the object oriented design is concerned, okay, a specific implementation of an operation is called the method. Okay, remember these things. These four are essential characteristics. Now let us look at what is object oriented development actually. Okay, actually object oriented development doesn't just mean to design itself. Okay, so it actually refers to the complete software development life cycle. Object oriented development, so it is incorporated, I mean like it is involved in analysis, design as well as implementation. Okay, so the essence of object oriented development is the identification and organization of these application concepts. Okay, rather than like just their final representation in a programming language and how do you actually implement it. Okay, so object oriented development is about this sort of identification and organization of these sort of application concepts. Okay, in the past much of this sort of community, object oriented community, actually focused at these sort of programming languages. Okay, okay, that's how like say for example programming languages like Java have actually evolved. Of course, like we'll be learning Java as part of the labs. Okay, so we will also be looking at the implementation features as well as part of this course, okay, in total. But let's see the point. The real payoff actually comes from addressing front-end conceptual issues rather than the back-end implementation details. That's where like the beauty of object-oriented development basically comes from. Okay. But if you start focusing at the implementation details from the beginning itself, then you are basically restricted by some of your design choices. Okay, so object oriented development is fundamentally a way of thinking, not a programming technique. So this is something which we need to remember. And as I also mentioned, like it completely refers to this sort of software lifecycle. It comes from the analysis, design, and also the implementation. Okay, that's about object oriented development. It is not just implementation. Okay. Then looking at object oriented methodology is concerned. So this is a process of object oriented development and also the graphical notation for representing these object oriented concepts. Okay. So object oriented methodology will have certain stages. The first stage is called system conception. The basically like users basically conceive an application, okay, and then like say for example they try to extract certain requirements, and then like they basically formulate this sort of tentative requirements. Okay, so that's about system conception. Okay, once this basic application has been thought about, okay, and the requirements are basically charted about, then comes the actual analysis. The actual analyst basically scrutinizes and regularly restates these sort of requirements from the system conception, okay, which is from the earliest stages, okay, and then like he basically constructs the models, okay. And what are these models? An analysis model is a concise and precise abstraction of what the system must do, what it must do. So we are basically trying to get this sort of precise abstraction for it. Okay, that's about object oriented methodology. Of course, in terms of analysis model is concerned, there are two parts of this analysis model. Okay, the first one is this domain model, which actually, of course, the next one is this application model. In the domain model, like we actually provides the description of real world objects that are reflected within the system. So now say for example, like you are trying to think about some sort of stockbroker application. So all the stocks, bonds, trades, commissions, all these will be classes, and then like they will have their own objects. Okay, so you have to model all of them. But when you come to this sort of application models, application model basically consists the parts which are actually visible to the user. Going with the same example, these application objects basically control the execution of these trades, and basically these values will be presented to the user. Okay, this is the second stage of object oriented methodology. Then basically comes this sort of system design. Okay, so basically the development team will devise like high level architecture for that particular application. Okay, then they also must decide like what performance characters to optimize, and then like tentative resource allocation. Okay, so for example, on what sort of servers it should run, what would be the architecture for it. They have to basically worry about all these things. Okay, this basically comes into system design. Okay, then basically there comes this class design, where like we actually add the details to the analysis model in accordance with this sort of system design strategy is concerned. Okay, in this class design, like we will also elaborate both domain and application objects, which we have discussed in the analysis days. Okay, with this sort of OO concepts and notation. Okay, we have to elaborate these things. Um, the main focus of this sort of class design is this sort of data structures and algorithms that are needed to basically implement each and every class. Okay, so yeah, once we go further, like you will have everything will be clear for you, and then like as part of the labs we will also try these things. So basically that's how like you will understand this sort of methodology is concerned. After the class design is ready, then you will actually start thinking about implementation. So the translate these sort of classes and the relationships which are actually developed during this sort of class design to a programming language. Okay, say for example, or say for example to a database or a hardware. In our case, like say for example, like we will take these object oriented designs and then like we'll convert them to Java, and then like we'll try them as part of the next. But see one thing, object oriented methodology is not actually pushing this sort of waterfall model. So it is not saying like you take an example and then like collect the requirements. Yeah, okay, basically like analyze it, design it, and then like develop the class diagrams and then like implement it. It is not like that one. Actually, object-oriented methodology actually pushes this sort of iterative development, where like you will go through all these stages of this OO methodology in iterations. Okay. Of course, like you will be carrying the same classes across all these stages and all across these, say for example, without much change in the notation, and these classes will be used across several iterations. Okay, Of course, like with each and every stage, like they basically gain additional information at later stages. That's about object-oriented methodology is concerned. There are three different models, okay, to describe systems from different viewpoints. Okay. Uh, Remember this one, each of these model actually applies to all stages of object-oriented development. Okay. So those are this class model, state model, and interaction model. We will discuss all these three different models in detail in the next videos. Okay. But then like let us try to see those things. What's a class model is? This basically describes the static structure of objects in a system. Okay, whatever the application you are trying to develop, this class model will consist of all this sort of static structure of the objects in the system. Then comes the state model, which actually describes all the aspects of an object that actually change over the time. Okay, that's about state model. Then comes the sort of interaction model. This actually describes how these different objects which are within the system operate among themselves to achieve broader results. Okay, this course is about looking at all these models. Okay, so the class models, state models, and interaction models. This is what we will be learning as part of the complete course. And in the next video, like I will discuss in a little bit of detail, like what each and every model is developed. So these are about three different models of this object-oriented development is concerned. So then let us look at some of the object-oriented themes. Okay, so these themes are like abstraction, encapsulation, and the combining of data and behavior, and sharing, and emphasis on essence of an object. Okay, and then like synergy. Okay, let us see each and every one after the other. Okay, in the coming slides. So abstraction. This abstraction lets you focus on essential aspects of an application while ignoring the details. Okay, if at all you are trying to develop an application, what are the essential aspects of an application? Okay, that is what we will be looking at. And object-oriented development fundamentally takes care of that one. The focus is on object, what an object is, and what it does. Okay, that's how like we will be looking at it. Its basic data structure and its behavior before actually deciding like how we will actually implement it. So the abstraction is a thought process actually. Okay, so it is the most important skill that is required for this sort of object-oriented development. So you should be able to think about all the objects lying there in an abstract way before you actually start thinking about how you actually implement them. Okay, this is the essential part of object-oriented development. Another very interesting theme is this encapsulation, information hiding basically. So this is using encapsulation, you actually separate the external aspects of an object which are actually accessed by other objects. Okay, say for example, if an object has certain features and then like certain operations, you will not be exposing all the features and all the operations to outside entity. There will be like, say for example, you will be separating what will be visible to outside from all the sort of internal implementation details of that object. These things will be hidden from other objects. Okay, encapsulation is a very interesting feature. In object-oriented programming, encapsulation basically refers to this sort of bundling of this data and the methods that actually operate on this data together. Okay, and then like restricting of direct access to some of these components. Of course, like some of these things you will be exposing so that like which the other objects can interact with, and some of the objects features and then like these methods. Okay, so the data and then like methods you will keep it, you will hide them, so that like no external object can access them. What would be the advantage of this one? Say for example, tomorrow if the implementation of this particular object changes, you don't have to change all the references and then like every other object which is actually referencing, you don't have to change the structure there. Okay, say for example, if you are going to change to fix some bugs or like say for example improving performance, if you change something here, you don't have to change all the references and you don't have to go to every object and change how objects of the I mean like from the same application how other objects actually are, they are not affected by this. Regarding the other themes are concerned, of course now you already know. Okay, so we are trying to combine the data and the behavior. The methods will be the behavior and the data is the basic data which is actually within that particular object. That's also one of the very interesting object-oriented theme. Okay, and then sharing is also another very interesting object-oriented theme. So basically inheritance of basically using the inheritance, like both these sort of data structures and behavior of the superclasses are shared by the subclasses. Okay, and they also basically like share this sort of common code, okay, among these subclasses. And again, the most important thing in object oriented is objects. So there will be special emphasis on the essence of an object, places greater emphasis on this sort of data structure, and lesser emphasis on this sort of procedural structure, how you actually implement it. Okay, so a specific emphasis will be given to this sort of objects. Then basically comes this sort of synergy. You can think about identity, classification, polymorphism, inheritance individually, okay, and you can actually use them in isolation, but together they actually complement each other. Okay, that actually is the essence of this sort of object-oriented mechanism is concerned. There are several advantages of object-oriented development. So they were basically used, I mean, like during the last 10-15 years. Okay, so 1.5 decade or 2 decades. Okay, it was used for developing different compilers, graphics, user interface, databases, object-oriented languages, CAD systems, simulations, etc. It was used everywhere actually, to be frank. Okay. It was also used to document existing programs, and they're like that are real structured. Okay, say for example, using object-oriented development, like you can actually document these things, the problems of them. Okay, and then like say for example, if a development has already happened, what are the difficulties in that one? You can actually document all these things. Remember this one: object-oriented development will not reduce the development time. Okay, if at all that is the perception people are thinking, it is a wrong conception. Okay, in fact actually it may take more time than the conventional development using this sort of object oriented development. Okay, so first you have to think in terms of design. Okay, so analysis, design, and then like basically come to the development. And we have seen about all the different stages, how we actually go through them, and how these classes and objects are actually reused across all the stages and across these iterations. Of course, by doing all this thing, like fundamentally it will promote this sort of future reuse. Okay, and of course like reduce downstream errors and maintenance. Okay, here it is also interesting to discuss like the reuse is a little bit abused in terms of object oriented development is concerned. That reuse part will not come easily. Okay, so you have to give enough thinking as well, enough time as well into, say for example, whatever the software you are developing using object oriented development, you still have to think a lot how certain parts can be reused. Okay, so all these things like are part of this sort of object oriented development we will be learning as part of this course. We will also take care of this sort of design and development as well. So as part of the references are concerned, as I already mentioned, like we'll be using this object-oriented modeling and design with UML, okay, Michael Blaha and James Rumbal. Okay. For other videos, like if at all, I will be using other references, like I will be putting those things as well. Okay. Thank you very much for your attention.